about a particle motion problem is that you have to understand the problem. You have to understand what they're asking for. So when you see acceleration at time t equals c, that means you have to find the acceleration. Acceleration is the derivative of velocity. Yeah, okay. And let's see, total distance traveled, that is the absolute value of velocity. The absolute value is important because everything has to be positive. When you see initially, that means time is 0. And at rest is when velocity equals 0. When you see that the particle is moving right, that means velocity is greater than 0, or it is positive. And when the particle is moving left, the velocity is less than 0, meaning it is negative. When they ask for speed, that's just the absolute value of velocity, because speed is always positive. Okay, particle is farthest left or right. What you do is compare positions at the endpoints and at local minima if it's asking for the farthest left, or you find the maxima if it's asking for the farthest right. Okay, here's the problem. Here's the graph. You see, that's the graph. Okay, so here's the first question. Find the acceleration of the particle at time t equals 3. So we know that acceleration at time t equals c is the derivative of velocity. And since velocity is given, we find the derivative. Here we go. You see, to find acceleration, we find the derivative of velocity, and that's cosine t squared times 2t. And when you work all that out, you get negative 5.466. Okay, next problem. Let's see. Find the total distance traveled by the particle from time t equals 0 to t equals 3. Right here, total distance traveled. You go from A to B and you find the absolute value of velocity. T equals 0 being A and t equals 3 being B. So you do from 0 to 3, and sine t squared is an absolute value, and we work all that out. It's 1.05 units. Don't forget the units.
1.705.
What? 1.705.
7.0.
Okay, whatever. Question number C. Find the position of the particle at time t equals 3. That means you have to find the antiderivative of velocity since it's given. So from 0 to 3. And so we plug in, when we find the antiderivative, we plug in 3 and 0. And when we do that, you get 0.774 for x of 3 and 5 when x equals 0, because in our original problem it says the position at time t equals 0 is 5. So there we go. When we add those two together, you get 5.774. Okay, last problem. For 0 is less than or equal to square root of 5 pi, find the time t at which the particle is farthest to the right. When it's farthest to the right, if you see right here, particle is farthest to the right, compare the positions at endpoints and at local maxima, because it's to the right. So here we go. The endpoints are 0. Okay, the endpoints are at 0 and square root of 5 pi. There we go. At endpoint x equals 0, it's 5 because it's given in the problem. And at x equals square root of 5 pi, it's 5.752. And then if you see in the original, there's like 2 other maximas. So we find the first maxima, blah blah blah, you get 5.895. The next maximum, you plug it in and you get 5.788. Now you compare these two and see which one is the highest, and that would be at x equals a. There you go. That's where it is farthest to the right, meaning farthest to the right. Where is it? Oh, whatever. AP Cal student. Hey.
I'm in love with the coco. I'm in love with the coco. I got it for the Lolo.
What's up? Nah.
Nah, stranger over there.